Okay, so in this video we're going to be doing differentiation. We're actually starting differentiation. Now differentiation has a lot of applications to it, right? One of them would be like to find the gradient of a curve at a certain point. But we're not even going to deal with that right now. What we're going to deal with is the notation, right? So the differential of y is written like this: dy over dx. This is telling us that we are differentiating y with respect to x. So we write it dy over dx, right? So this is basically like the formula, right, as to how we go about doing it. So this video is just to get you acquainted to the formula and to be able to differentiate functions, and later on we'll deal with applications of differentiation and stuff like that. Okay, so if you have a, which is some constant, multiplied by n raised to a power, and you're going to differentiate it, what you're going to do is bring down you're going to bring down n and multiply by a, so you got n a or a n, and you're going to reduce this power by 1. Okay, so let's look at some examples. So the first one that we have is y is equal to 2x to the power 3. Now this is really simple, right? So okay, this marker not okay, so I just want to change the marker. Apparently that marker had no more ink. Alright, so we're going to do this, right? So dy dx, which is the notation, right? So we said we're going to take this, bring it down, and multiply. So we're going to take this, bring it down, 3, going to times by 2, we're going to get 6, right? We're going to put back our x, reduce this by 1. If we reduce 3 by 1, we're going to get 2. Okay. I'm going to do it again. Right, so dy dx, take this, bring it and multiply by the number in front, so 5 by 5 is 25. X, reduce this by 1, take away 1 from 5, you're going to get what? You get 4. And that's it. Ain't none that complicated. Alright, so this one, they wrote it a little different, but we know how to change this, right? To bring it to look like x with some power. Good. So if we want to bring this on top, we know this could be written as x. If we bring that on top, we know it will change to -3. Right? We know that from indices. So now we could go ahead and do our thing, right? Let's differentiate. So dy dx would be taking this -3 and bring it in front and multiplying. If it don't have a number, we know the number that exists in there is like a 1. So we just bring it. So it would be like -3 times by 1. We can write a 1 here that we don't need to write. We know it there. Right? So this would be -3 x. Now -3, if you take away 1 from that, you're going to get -4. Right? So don't confuse that. And you're done. So you're going to go on to this one now. Same thing again. Square root. If we had to write it as a power, square root as a power is a half. We do have a number in front, if you understand, is 1. So if we take this half and bring it in front and multiply by 1, we are going to get a half times 1 is a half x, and this here reduces by 1. So I'm going in my working column here. A half take away 1. A half take away 1. You could put on your calculator or work it out as -1/2. So our power is -1/2. And that's it. Alright, so we're just going to continue with some more examples. So we have this one here. Notice we have cube root underneath here, right? So the first thing I'm going to do is fix that. So it's 1 over cube root is to the power 2, right? So before I can even move it and bring it up on top, I have to fix that. So that now if I go to bring it up on top, we change to -1/3. Right? We know that from indices. And now I could go ahead and differentiate. So alright, here dy dx then would be, okay, we're going to bring this -1/3 and put it in front. So it'll be -1/3, take away 1. So we will get -1/3. So our power will be -1/3. Or if you want to put that as a mixed number, it's up to you. All right, so didn't do anything like this. If you just have like 5 and x, right? So if you just have like a constant with x and you differentiate it, dy dx will just be, you just drop off the x, so it'll be 5, right? And I could actually prove that. So what you could do is just memorize that. Like, let me say if you have y is equal to 10x, dy dx will just be 10, right? So I'm going to show you how that we get this answer without having to actually do a set of working. Alright, so when you get a question, do this. I'm just showing the proof on the side, right? So y is equal to 5x. If we don't have a power, we understand the power is 1. So we're going to take 1, bring it in front, and multiply, right? 1 by 5 is 5x. And on top here now, we remember to be 1, take away 1, which just give you 0. Alright? Anything to the power 0 is 1. Right, so if you get a question, don't do all this, you can just drop off the x. So this is something you will have to kind of note. Alright, so we're going to do this one now. So look at writing, it's the same thing. We're going to differentiate this, put the answer, this, put the answer, this, put the answer. Alright, so let's do this one first. We're going 3 by 2 is 6. X, reduce this by 1, we're going to get 1. Remember this is right? Remember we just show how to deal with this, right? So we could just drop off the x. Now, we didn't deal with this yet. Anytime you differentiate in a constant, that constant will change to 0, so you leave it out. And this is your answer. Okay, so this is just an next one that we're going to do. Remember we're finding the differential of each part of it, right? So if we differentiate this, bring this and multiply 3 by 6 is 6 3s are 18. Reduce this by 1, we'll get 2. 2 2s are 4. X, we're reducing that by 1, we'll get 1, or you can just leave it as x. Now, we say when we have like we have 2x, we'll just drop off the x, and we get 2. So this x by itself we know is 1x. So if we drop off the x, we know that is 1. And we said anytime it's a constant, it's going to 0. So that's it.